Hi everyone and welcome to this video on investigating associations between categorical variables. Really should make these titles much shorter. Hi, my name's Darren and I'm the Maths Guru and welcoming you to this video for the Further Maths Units 3 and 4 course. Thank you so much for joining. If you haven't already done so, there is a doohickey in the corner that will allow you to subscribe. There is also shown above a link to mathsguru.com, which is the website that has all of these videos in order by chapter and textbook with downloadable notes. So head on over there and sign up, it's free. And knock yourself out. Okay, so basically the second video in the series, the first video led with the idea of what an explanatory and a response variable is. And this becomes more and more important as the videos progress. We need to know how to best relate information that are categorical in nature, categorical, numerical, and numerical, and numerical. And then obviously once we can do that, we can then start analyzing the data or analyzing the data. Please, Further Maths, ladies and gentlemen, is a much easier course in mathematical methods, but it is here for you to interpret the results. It is not just number crunching. You have to be able to understand what you're doing, and that's hopefully what I will provide you with. So in the previous lesson, we looked at the idea of explanatory and response variables, and if you remember, explanatory goes here. So that's my explanatory variable, and my response variable goes up the side. And if you remember rightly, this one here is the one we're looking to predict from our explanatory variable. So for example, as we say here, we may have time along the x-axis and distance along our y-axis, and so time in that situation would be my explanatory variable. And understanding the differences between these two and how they are linked will become more and more important. So we've noticed that there's lots and lots of things that are probably associated. As I said, probably age and height, exam scores and IQ. That's a bit of a contentious ones. Hopefully the higher IQ someone has, the better they're going to do on their exams. And what we say is when there is a link, they are associated. Right? Now we need to be very careful because later on videos start to talk about how that association can be described. We can use graphs to show these associations. We've just done that a moment ago. That was with a numerical data and scatter plots or line graphs are really good for that. But we can also use something called two-way table. And two-way tables are really good for categorical data. So what you'll notice here, and this is an example from the Cambridge Further Maths Units 3 and 4 textbook, and they've given me permission to use all their examples. Thank you very much, Cambridge. We have here is a simple question. Is a person's attitude to gun control associated with their sex? Okay, so we've gone out, we've done some sort of a survey, and this survey seems to have had just two questions, all right? One, what is your sex? That is categorical data because it's male or female. And two, are you for or against gun control? And what they've done is they've then summed these values by sex. So we've got 58 males were asked and 42 females were asked. And the raw data was placed here. So 32 males were for, 30 females were against. And so what can we draw from this? Well, at the moment, there doesn't seem to be any real significant difference between the number 32 and the number 30. Can we compare using this information? My answer is no, you can't. Why? Because you had different numbers of people asked. So we're going to have to use something that we've been using in maths since year 9, and that is percentages. And when we turn things into percentages, we much better compare raw data. So we need to decide which is the explanatory variable and which is the response variable. So first things first, these tables are always drawn where the response variable is the row data. Do you see what I did there? Response and row. So these here, and my attitude is my response variable and my sex is my explanatory variable. All right, so that's interesting to know, but what about, is there an association? Well, that doesn't help us convert these things into percentages. How do we do that? Well, at this moment in time, if I want to turn this into a percentage, the number of males who are for, then there were 32 males for out of 58 in total. So bringing up my calculator and clearing all the data we had before, 32 divided by 58 is going to give me 0.55. Remember, to turn that into a percentage, you times by 100. So 55.1%, 55.2% if we round to 1 decimal place. And what you'll notice here, there is 55.2% in there. Let's just check one more value. Let's check this, 12 females. In this situation, we had 12 females out of 42. So 12 divided by 42, hit enter and times by 100. Gives me 28.6, and there we go, ladies and gentlemen, 28.6. So what I've now managed to do is turn all of these values into percentages, and once they're percentages, they're all scaled out of 100. That's what effectively a percentage is, and we can now better compare. And what do you notice? Well, rubbing these two values out now, and let's just have a look. The number of females who are for gun control is 71.4%. The number of males, 55.2%. Now, basically, the last part of this question, or the last part to be able to answer this effectively is there a significant difference between those two values, or any two values you're looking at? Likewise, if we looked at the against, 44.8 and 28.6. Well, I don't know about you, I reckon 55 and 71 is significantly far apart, and so now I can state from that table that there is a relationship between sex and attitudes for gun control. Okay, now we would obviously want to write that in some form of a report, and taken again from the Cambridge book, this is a nice idea, or a boilerplate code. You've got to put in percentages. I'm going to scroll that back down again and leave that in. All right, let's get rid of this information now. You have to put in percentages whenever you write a report. So we say from table 3.2, we see that a much higher, in your exam, you probably won't be labeling your table. So you'll probably say from the table. We see that a much higher percentage of females were for gun control than males, 71.4% to 55.2%. Notice what we did there? We put the percentages in. Indicating, all right, so now we're going to drive this home. We're going to say to the examiner, I'm going to now answer the question, indicating that attitude to gun control is associated with sex. Now, obviously, there may be percentages that aren't significantly far apart. Maybe 50 and 55%. Is that far apart? Probably not. In which case, in that situation, so long as I can back it up by putting my data in my sentence, I might turn around and say there is no association. Putting this into practice, and again taking examples from the Cambridge Further Maths textbook series. A survey was conducted with 100 people. Now, if it's 100 people, that's great, so long as the totals are all 100%. As part of the survey, people are asked whether or not they supported banning mobile phones in cinemas. As far as I'm concerned, we should ban talking in cinemas. Really annoys me, all right? If I'm in a cinema and you are sitting there talking, do me a favor, go home. No, do not talk in the cinema. Agree with me? Put a comment. Disagree with me? Put a comment. Let's argue it out. But the question goes on to say, is there an association between support for banning mobile phones in cinemas and the sex of the respondent? And so let's have a look again. So what do we have here? Sex, male or female, categorical. Banning mobile phones, categorical. Response variable is my row data, and this would be my explanatory variable. So is there an association? Do you see a significant difference in the percentages? Well, I do. I think 65% and 87.9% is fairly large. And so I think there is an association. And as we can see here, there is a sentence we can write again, putting our data in, that says, yes, there is an association between the percentage of males in support of banning mobile phones in cinemas was much higher than for females. Job done. Second example, and they all become a little bit, what's the word I'm looking for? A little bit samey, actually. In the same survey, people asked whether or not they supported Sunday racing. Okay, the results are summarized in the table below, and this is a brilliant example of what I was just talking about. So, do I have categorical data there? Yes. Categorical data there? Yes. Are my percentages already worked out for me? Yes. Which one is my response variable? It is the rows. This is my explanatory variable. And so, what are we turning around here? 55.6 and 54.5, they are fairly close in terms of percentages, and so there is no association here as far as I'm concerned, or as far as the textbook is concerned. Now again, in an exam, you are either going to have them really close together, or really far apart. I don't think it would be fair of us to make them, I don't know, 5 or 6 or 8% difference, right? Because that's a little bit subjective. So once again, we can take that information and say, no, the percentage of males supporting Sunday racing is similar to the percentage of females. Again, notice the words similar, bigger, smaller. We're using all of these to reference our results. Now, believe it or not, we don't always have to have just two categorical data for both my explanatory and response variables. We can have, in this situation, 3, 4, it doesn't really matter so long as the data is categorical. Can you test that? Is that data that I've just highlighted categorical? Yes. What about smoker, past smoker, never smoked, categorical? Absolutely. These are my response variables. These are my explanatory variables. So the question says, there are 2 categorical variables, but each one has multiple categories. What do? Well, we could draw a segmented bar chart that helps us understand. This is what the textbook does. I don't think it necessarily helps, because what I'm looking for is some sort of pattern, some sort of decreasing trend, some sort of decreasing number or increasing number. And so can we see whether education level and smoking status are associated? Well, I think absolutely it is. Because if we look at the numbers I'm highlighting now, and that's really bad because yellow on purple is not a great color. What do we notice? Smokers, 33.9, going down to 31.7, going down to 26.5, and going down to 18.4. So there is a definite decrease in all of this. And so again, I would say there is an association between education level and smoking status. And I would put some of those figures in to highlight it. Yes, it's decreasing from 33.2, 31.7 to 26.5 to 18.4. All right, and lo and behold, there is a report, again, provided by Cambridge, that says from the table, we see that the percentage of smokers steadily decreases. There's my qualifier, you know, increase, decrease, stays the same, with education level from 33.9% for year 9 to below to 18.4 for university. This indicating that smoking is associated. Don't forget to answer the question. Well, ladies and gentlemen, there we go. That is the end of this video. The key takeaway from this is that two-way tables are used to best describe categorical versus categorical, right? Or at least to analyze it. So remember that. It's going to come up in questions in the VCAA exam, I promise you. I'm done. Thank you very much. There is another video loading soon on this same chapter. All right, if you haven't already done so, could you subscribe and spread the word to your friends that these videos are there? Otherwise, I look forward to seeing you in my next video. Thanks for taking the time and watching. I'll see you again soon. Bye-bye.